Hey folks, today we're going to be working on problem 3. This is only problem 3 for limiting reactants. Here it is listed here. Notice with number 2, with this one, it's asking you for liters of nitrogen that are formed. Okay, so we're going to have to go work this problem and go to liters of nitrogen. So, let's see what we have here. We have hydrazine, which is N2H4. And we're adding to it hydrogen peroxide, and you should know that hydrogen peroxide is H2O2. You should be able to figure that out. And it's producing nitrogen gas. Nitrogen's N2 and water, which is H2O. We now have to go and balance the equation. Well, we notice we have a bunch of H's on the left, and we don't have as many on the right. So, let's see, we have to have 2 of these over here, and 4 of these over here to manage to get our oxygens to balance. So we still have 2 nitrogens, we've got a total of 8 hydrogens, and we've got a total of 4 oxygens. So we are now all balanced. That's great. Right. Now we do have to figure out what some things weigh, and we can figure out that N2H4 has a mass of 32.046 grams per mole. And we're producing, let's see, hydrogen peroxide. We have grams of that, so we have to figure out that H2O2 is 34.014 grams. And because we're producing liters of nitrogen, we don't have to worry about its mass. Okay, so let's go ahead and write down what we know. We have 25 grams of our hydrazine, and we have 66 grams of hydrogen peroxide. So let's work our problem through for N2H4, which is hydrazine. And we start out with 25 grams of hydrazine, N2H4, and we have to get rid of grams of hydrazine and go to moles of hydrazine. And then we can go from moles of hydrazine N2H4, we can go to moles of, and in our case we want nitrogen gas. And then we can go from moles of nitrogen gas to liters of nitrogen gas. Right? So that one's pretty easy. 1 mole of N2H4, we figured out already that it weighs 32.046 grams per mole. And my relationship between hydrazine and nitrogen gas is 1:1. And my relationship of moles to liters is 22.4. Alright, so if I work that problem out, I'll find out that this gives me 17 liters of N2. Alright, let's work it out again, but this time we're working it out for hydrogen peroxide, which is H2O2, and we start there with 66 grams of H2O2, and we have to convert from grams of H2O2 to moles of H2O2, and then we have to go from moles of H2O2 to moles of our target, which again is N2, and again we have to go to liters of N2. Alright, so let's see, 1 mole of H2O2, we have figured out that that has a mass of 34.014, and moles of H2O2 is 2, and nitrogen gas is 1, and moles of N2 is 22.4 liters. When we work that out, we get a total of 22 liters of N2. If we subtract those, clearly we're going to have 5 liters of 5 liters left over. So we have 5 liters of N2 left over, and we're going to convert that back by using 22.4 liters of N2, and we're going to moles, and 1 mole, let's see, N2, 1 mole of N2 takes me back to, what is our excess? Our excess is H2O2, so that's 2 moles of H2O2. And then from moles of H2O2, we have to go back to grams of H2O2, which is 34 grams, 34.014 grams per mole. So that gives us a number of 15 grams of H2O2. Now, unfortunately, we only have one sig fig over here on the left, so we're going to have to round that 15. So it's going to end up to 20 grams of H2O2. Now, I don't like that. Just go with 15 at this point, and we'll leave it there. Okay? That's it. See you in class.